Hey, welcome to Smart Architectural Programming. My name is Mohammed, and coding alongside me is.
George. And today, we'll be kind of going over a simple Flask, um, application, doing some mainly like cryptography, right? We wanna pretty much disguise, the authentication. I think Muhammad will get a little more into that, but I'm not really, to be honest, I'm not really too familiar with what this thing is doing on the back end, but we kind of need this for, um, for, is it masking the authentication, Mohammed? What exactly is this thing doing?
It's basically, converting your password into, using a certain key into, but shifting the password's letters using a key
Mm,
that's randomly generated. So even if someone accesses the database, unless they
yes.
know the specific key, they can't, just pull up all the passwords or hack into account or just get complete free reign over the entire
Mm,
application. And in this
beautiful.
case, we're leveraging 256
Yes.
256 encryption methodology, which is mainly used in a lot of professional scale applications. So this,
Yes.
if you're able to implement this, you know how to professionally implement a authentication system that's not just a simple authentication system, but it's extremely secure as well.
Beautiful. Now, you know, what he said. So Muhammad knows a lot more about this algorithm, and we're going to be leveraging Fernet, which is a certain cryptography library in Python in order to do all that beautiful back end work that Muhammad was talking about. Now, the reason we're doing this is that we're going to be building a larger application, and this is one of the features. So I think we'll think about if we're going to make a kind of a larger piece of content, from cradle to grave, etc. But without further ado, I think we'll get into kind of breaking down and showing you guys how to implement this particular application. And Mohammed, on a high level, also, if you can kind of break down, you know, uh, from a high level perspective, exactly what's going to happen here.
So basically, I think in one of our previous videos, we implemented a simple authentication feature, right? So with that authentication, we were using a very normal, hashing methodology where we were just, crypting our password in a very basic way. Now, you know, in reality, such you could say ciphers are very easy to break. Like an algorithm can break ciphers very quickly. So if you have like a 7-word password and it just contains letters A to Z, right? So there's only there's only a certain amount of combinations that a user can use those letters in a 7-letter word. And modern computers are so powerful that they can easily run all of those combinations in a brute force attack within within a minute or less. Like I'm not exactly sure, but like that shows how weak certain crypting methods are. So we need to we computer scientists have identified different ways, which makes it very difficult for for a computer just simply break into a password. The current computers don't have that capacity to brute force and identify that password. Uh, like there are other techniques as well, such as limiting the number of login attempts, so on and so forth. You'll notice that within your iPhones or your iPhone accounts or your Gmail accounts, that after a certain amount of logins, they just put a pause on it so that brute force attack cannot continue. So yeah, but that's a conversation for another video. But what we need to focus here is the encrypting methodology. So 256 encrypting methodology is something that's very commonly used in uh, professional scale applications, and it's very difficult to decrypt, and that which means that your application becomes much more secure because not all cryptography method encryption and cryptography methods are the same and are secure. So Right now this is secure, but like, it's a constantly changing field, and we need to make sure that we are constantly updated on what encryption methodology at that certain time is considered secure. So now we can move forward to our main application. So these are all the different libraries that we're importing, and they go right at the top of our application. Uh, for basically most of these libraries we've already discussed in a previous video, but I'll just go over them quickly. But they're very, you can say, standard libraries that use in a Flask Flask application. So we're importing Flask, then we import all the standard Flask applications, Flask methods from the Flask app library. Then we import, we import SQL Alchemy from Flask SQL Alchemy, which is a database, I think ORM that we're using to set up our database. Then we're importing the Flask login library to manage the login features for an application. The Flask WTF is basically a Flask form library through which we can create Flask forms. Then there's WT forms, through which we are importing the different basically these fields here. These are basically the different types of restrictions on the data types, length, so on and so forth, for a database column that records and stores information. So we're importing that, so we don't need to specifically define these things, and we can just refer to these individual methods to automatically define all of that within our database. And that's how ORMs make life so much easier for programmers who don't need to micromanage small scale instructions on SQL or any database, and they can just use an ORM to handle most of the database based actions. Then we also import from WT forms and validators, data required, length equal to. Again, these are similar, like their restrictions and other factors that we need to add to the form. And then we import JWT, and then we import cryptography fernet and importing fernet. Now this is important because this particular library is what is an important aspect of this video, where we are basically creating the encryption key based on 256 encryption methodology. And we're importing datetime. That's mostly to record when the user is registered or when the user logs in, so on and so forth. If you'll notice
and real quick, Mohammed, I just want to just kind of throw this in here. For individuals that are not seasoned developers, I just want to explain that Flask is just a simple framework that you can use to spin up quick microservices, right? Now, if you're building like larger applications, enterprise applications, etc., you may want to use something like Django. So when you see all this, this Flask, using this particular framework, that's what that's all about, right? So just wanted to kind of give that breakdown. Go ahead, Mohammed.
Yeah, I think the having perspective on the framework we're using is also very important. So yeah, so basically Flask is a framework that we're leveraging here, and yeah, so that's why there's a lot of mention of Flask, and there are all those different Flask libraries we're using, as George mentioned earlier. On that point, right, once we've all gone over all the imports that we're doing, you'll notice like some of the imports are like are not that sharp compared to the other ones on this IDE, and even some of the methods are not sharp. So I didn't delete these because I wanted to show this to you. What this represents is that these methods or these imports are not being used in the entire application anywhere, but either way they're already imported here. So if you're not using something, delete it, because that is adding code to that is adding loading time to your application, which reduces the speed. So we're not using request here, so we can remove that method from here, and we're not using JWT, so we're going to remove that library here as well. So moving forward, now this is a standard way we initiate the Flask application. So I mean, yeah, you don't need to go too deep into it. You can just use the same syntax to initiate a Flask application. Then we use app.config to set up the secret key for the Flask application. You can set whatever secret key you want here. I'm just going to go with your secret key here for the time being. Then we use our app.config to set up our SQL Alchemy database. And then we initialize our database and the login manager. So see, data, initializing database, we don't need to go too deep into that. Login manager is there so we can manage how we log in and log out users. So that's a Flask function. So we need to initialize it if we want to use it. Now, the important part of the video is here, encryption key. So we save an encryption key using Fernet, and Fernet randomly generates keys through which it's going to basically shift the password in a way to cipher it basically. So one of the a tidbit here, like one of the most initial ciphers that we used humans used was during Julius Caesar's time, and it's called Caesar cipher, and it's one of the most common programming ciphers that you're taught when you're first learning about ciphers, and it's a very simple cipher. So I can if I can show you here, like if you type in A and your key is, let's say, key equals to give me a second, we have a key that equals to let's say 4. So A is going to shift by 4 letters: A, B, C, D, E. So shifting A by 4 equals to E. And that's a very simple way how we can explain what a cipher is, right? In a very simple way. Like Caesar cipher is probably the oldest way to encrypt communications, and that's how Julius Caesar basically communicated with his forces and his troops and his generals, basically by making sure his messages were encrypted. So now that we basically understand what an encryption looks like, practically, we can come back here. So this key is randomly generated, right, using Fernet. And then we save this key in a Fernet object using Cipher Suite as the object name that we're going to basically leverage down below a lot of time to basically work with this, with this key. Then we just set up a basic user model. What we need: an ID, username, password, and email. Basically, that's how we're setting up our database using the SQL Alchemy ORM. And then we just use the login manager user loader. We define that, how we can load users, get users through our database. Then we define the login form. Then we define the registration form, and both of them are using Flask form, which is from the WTF WTF library that we imported above. Now, this is a very important aspect, right? Never forget, after all your models and before your routes, you need to initialize your databases using this syntax with app.appContext db.createAll. This actually implements all the models that you defined and creates the databases. If you don't do that, regardless of your logic being correct, you're going to keep having these database errors popping up, and you can't resolve them until initially when I started out programming, this was one of the most annoying things that happened over and over again. Like, all the logic was correct. I was running the db.createAll right at the end of the application, and basically the db.createAll was about here, where we actually set up the features to run the Flask application. You need to initialize your databases using this syntax with app.appContext db.createAll. This actually implements all the models that you defined and creates the databases. If you don't do that, regardless of your logic being correct, you're going to keep having these database errors popping up, and you can't resolve them until initially when I started out programming, this was one of the most annoying things that happened over and over again. Like, all the logic was correct. I was running the db.createAll right at the end of the application, and basically the db.createAll was about here, where we actually set up the features to run the Flask application. But the issue that comes up here is that we have all the features implemented above, so creation of database down below usually does not result in a database being created that we can work with.